Okay, question 9 is our integration by substitution question. It looks quite awful, and unless you don't panic, it could be quite a tough question. Let's just start by writing the question out. So I'm going to go straight in as you normally do, which will always get you a mark, and differentiate what they've given us for the substitution. So if u is 1 plus natural log x plus x, then du by dx, and this will, you're guaranteed to get a mark for this, 1 over x plus 1. We're then going to rearrange that to say what dx is equal to. So du is going to be equal to 1 over x plus 1 times dx. So dx is going to be equal to du over 1 over x plus 1. But that looks quite messy, and it's really important in this question for us to get rid of this fraction in the fraction, and I'm going to do that now by timesing the top and the bottom by x, which will get us x du over 1 plus x. This is a very important step, and you'd struggle to get the substitution to cancel down if you didn't do that step. So that's what dx is equal to. The next thing we need to worry about is these logs. Now this one's fine, this is obviously just u, but what is going on here? We've got the relationship that u is equal to 1 plus ln x plus x. But what is minus ln x minus x equal to? Well, if we move these to the left-hand side, that pops out our minus ln x minus x. So if I now move this u to the right-hand side, we've almost got what we need. The only thing that we're missing is a 1, and we can add 1 to both sides very easily. If I just literally add 1 to both sides, we're going to get 1, take away ln x, take x, is equal to 2, because we've added 1 to the other side as well, take away u. So this bracket here is worth 2 take away u. This bracket here is worth u. So we've got loads of things we can substitute in now. So we can now rewrite the question as, what have we got? We've got 3, and I'm going to leave that bracket as it is, and you'll see why in a second. 3x plus 1 times 2 take u, which we've just swapped it in for, over x, which I'm also going to leave, times u. Times by dx, but we're not going to write dx, we're going to write x du over 1 plus x. And hopefully you'll see now why we left these two terms in, because they're the other things on the opposite way round with the du term. So that's going to cancel with that, that's going to cancel with that, and we're left with just needing to integrate 3 lots of 2 take u over u, which we can cope with integrating. How? We're going to do it by splitting up this is into 6 over u, so we're going to undo the fraction. So we've got 6 take 3u over u, but we can rewrite that as 6 take u over 3u take u, or just 3. Six over u is easy to integrate, that's just going to be 6 ln u, and when we integrate 3 we get 3u plus c. Don't stop now though, because we weren't being asked to integrate u in terms of u, we just used that as a method to help us integrate the original question. So the last job now is to swap u back for 1 plus ln x plus x. Don't forget that easy step at the end, and don't worry that we're going to be putting a log in a log. That's fine. 1 plus ln x plus x. and here as well, minus 3, 1 plus ln x plus x. And I would leave it like that. I wouldn't bother expanding any brackets or anything here. That would be my final answer.